All right, in the last video, we focused on the process of fission and how we can produce a chain reaction in order to produce multiple fission reactions in a row that can then release energy that can be harvested, turned into steam, run a turbine, and produce electricity. In this video, I'm going to focus a little bit more on the power plant itself and some of the factors that are important to be aware of as we consider nuclear power as a source of energy into our future. Now, if we look at power plants here in the US, there are about 100 working power plants currently. Now, this number is changing, but as of right now, there aren't too many power plants that are currently designed to be built in the near future, and we'll talk about that in a little bit. Now, these 100 power plants make up about 20% of the US's total electricity. And this is a pretty significant margin. And we'll see how that compares a little bit later on in this unit with other sources of electricity. But 20% is pretty substantial. Not as high as some countries, but a decent amount. Now, these power plants are retired about 60 years into their lifespan. So after about 60 years, a decision has to be made. Is this power plant going to be revitalized, so remodeled and rebuilt, or are we just going to let it retire? If we look into our future here, a lot of our nuclear power plants currently are going to be hitting that 60-year mark within our next 20 years or so. So it is important that we understand about nuclear power. What are some of the advantages and disadvantages going into the future to make a decision of, do we want to keep these power plants going, or do we want to leave them for some other source of energy? If you look here at Minnesota, you can see that there are 3 reactors that are showing up in our state. There are actually 2 power plants. One of them has 2 reactors. These power plants are the Monticello power plant here in Monticello, Minnesota, and then the Prairie Island power plant down in Red Wing. Prairie Island actually has 2 reactors. Those are the 2 silos there that you see, those concrete containment structures. And notice how both of these power plants are on bodies of water. Bodies of water are typically found around nuclear power in order to use the water as a coolant. So in case there is a meltdown or water needs to be used to cool down the reactor, the water is readily available if they are on that water source. You'll also notice that both of these reactors don't have that stereotypical nuclear power plant shape. So it's possible that you've driven past these and didn't even know that it was a nuclear power plant. Both of these are within 50 miles of Minnetonka and the Twin Cities. So they are not necessarily right in our backyard, but they are within range that you could potentially see them without driving too far. Now, the biggest aspect that we talk a lot about with nuclear power that is still kind of an unknown is the nuclear waste. So if you think back to the last video, that power that is produced out of that uranium-235 atom undergoing fission and splitting up, what we're left with is the byproduct of that fission reaction. It's not uranium-235 anymore, but we're left with this waste that is no longer uranium. That isn't usable in the type of nuclear power that we are using in these power plants. Instead, that is just basically useless waste, but it isn't harmless waste. Now, even though it is smaller than uranium, most of that is still pretty radioactive still. And a lot of these different isotopes that are produced have half-lives that are significant. So some are fairly short, like 28 or 30 years, is a relatively low half-life. That means that it produces most of its radioactivity in a shorter amount of time. So it actually makes it more harmful in the short term because it is releasing more alpha and beta decay in a given second or minute. But over time, it will basically become not radioactive anymore. It'll release that radioactivity. Now, some of these byproducts remain radioactive for millions of years. And that basically means that we can't just wait it out. We can't just put this fuel in a pile once it's been spent and just wait till it isn't radioactive anymore. That time scale is not something that is useful to humans. So what do we do with that radioactive waste? Well, there are a couple different answers to that question. And there's actually stages of what we do with that nuclear waste disposal. The first stage, after it is no longer usable in the nuclear reactor itself, and when I say no longer usable, it's actually a pretty short duration that it can be used. Um, Only about 5% of the uranium is used in that process, and is considered spent fuel typically when that number gets down to like 95% or less, which isn't a terribly efficient process. But once that spent uranium is removed from the reactor, it is still very, very hot. So the first stop for it is to be dumped into one of these spent waste pools. These are giant pools of water that are on site. And the nuclear waste stays down there for a given amount of time for a couple reasons. One, to cool down, and two, because water is actually a really good shield of radiation. Down there, it's actually protecting really nicely from all the different people that could be walking by. That radiation is not going to be getting really out of that water. Now, that is not a great long-term storage uh, because it is it has to be maintained quite a bit, just to make sure that there is still water in there. And also, it runs out of space. So once it gets removed from that spent waste pool, it gets moved out onto the property of that nuclear power plant into these dry storage spent fuel canisters. These are concrete silos, basically, with concrete walls that are several feet thick. Also, some steel walls around there, and the spent fuel rods are stacked up in the middle. And this is currently kind of where that nuclear waste is staying. So most of the nuclear power plants that are around the country have these dry storage spent fuel canisters just sitting outside on the property. Now they are very well shielded. Sometimes they're put into a storage bunker, so there isn't danger of the radiation getting out, but that is not a great long-term solution. It's kind of like every time if you took the trash out of your house and you just dumped it in a pile in your backyard, after a certain amount of time, it's not going to be a good solution. You need somewhere else to put that spent waste. So a lot of the conversation has been, okay, now what do we do with it? This isn't a great long-term solution. As an aside here, speaking of spent fuel, one of my favorite comics, XKCD, does a What If series. He has also written a book of the same name, and one of the blogs is about how dangerous it would be if you swam in one of those spent fuel pools. So I'll link that in our class today if you wanted to read that. It's a pretty entertaining read. Okay, so if we think about what the long-term solution then is going to be, it isn't those spent waste casks that are stored on site. Ultimately, we need somewhere to put this stuff. And for a long time, the most promising location was a place called Yucca Mountain in Nevada. Yucca Mountain is a facility and we've put many millions and billions of dollars into to dig a giant tunnel system down in the base of this mountain that we could then drive our nuclear waste to and store down below the ground. So basically bury the nuclear fuel. And this it was actually a project go along very well until about 10 years ago. It struck a couple of different speed bumps along the way. The first being which Nevada didn't really want this thing. They didn't want to be the waste facility for the entire country for the radioactive waste. So they pushed back pretty hard on that proposal. And number two, different states didn't really want that. So having this facility in Nevada basically meant that the nuclear waste had to be driven from wherever it was produced, most of it being on the East Coast, all the way through the country into Nevada. And for a lot of reasons, states didn't like the idea of the interstate system having this nuclear waste being driven along the highways. And the third reason is there are some studies that came out that basically talked about Yucca Mountain being on a more active fault line than had originally been thought about. So the possibility of Yucca Mountain shifting uh, basically halted, along with those other considerations, halted the production of this facility. Um, there was also a conversation kind of along that because other countries are looking at doing a storage procedure similar to this. When the storage of this waste is many, many millions of years for its half-life, it stays radioactive for a long time, very likely beyond our civilization. So there have been a group of scientists and artists that have actually collaborated to try to figure out what is the most appropriate way to mark if something is dangerous way out into the future, where language might not be something that can be used. Symbols might not have the same meaning. So I'll link a video as well, so you can see a little bit of that. That's a fairly interesting watch. So that leads us to this final question: are there better options out there? Nuclear fuel has a ton of advantages. It is able to produce a lot of energy without emitting CO2, like fossil fuels do when they're burning. It is fairly low cost compared to some of the options that are out there, but this disposal or the potential for dangerous side effects or explosions like Fukushima or Chernobyl basically give people a sense of caution when it comes to nuclear power plants. This nuclear waste is also a very big factor. There are lots of different options that have been presented. Most of them kind of point back to this idea about some sort of long-term storage, um, being above ground or below ground. Some have looked into disposing it in different ways, like down in the sea or subsea bed or in ice sheets. The most promising recently have been using new procedures that can then use that waste uh, to produce nuclear power instead of using the uranium. So basically recycling the waste instead of just storing it somewhere else.